yesterday, we talked about the idea behind what the confidence interval and the confidence level tells us. Today, we are going to go through that quickly one more time. But we're going to focus today on connecting that to what the structure of the formula is going to look like, to how are we actually going to calculate this thing. And we're not going to actually do any calculations today, but we are going to head in that direction so that you can start to connect the formula and the calculations going on with what we are actually finding and how we're going to interpret the value and what it's going to tell us about the data. So, I had said, this is saying something I said yesterday, which is a lot of times they like to have a distractor answer of the confidence level, talking about a percent chance that the confidence interval is correct. That when we say 95% confident, we do not mean that that interval is right 95% of the time. It's not what we're saying. What we are saying, this interpretation for confidence levels says that if we think about the population that we're trying to estimate as our target, either some proportion or percentage that we're trying to estimate or a mean, so let's take the mean. If there's some population mean that we're trying to estimate as my target, if we take random samples and construct confidence intervals from those samples, that percentage of them will have the target inside of the confidence interval. So it is the percentage of all the confidence intervals I can make that hit that target, that will have the mean in it. And so the interval itself is going to give me a range of values that we think are plausible for this parameter, for this mean or for this proportion. It gives us a kind of lower and upper boundary for here are the values that I think are plausible for the mean. And let's look at how that's actually calculated so that you can start to see where all these ideas come from. When we calculate an interval, this will get filled in just a second here. Right now it's just kind of hanging there. Give it a second. Ignore it for now. I talked about this yesterday as well, but we usually choose somewhere in the 90 to 95 range, because if we make it like 99 or if we try to get 100%, technically the only way to get 100% is to go from negative infinity to positive infinity. And to say, well, the mean is somewhere between negative infinity to positive infinity is not very helpful for us. So we're balancing high percent confidence with not too high as to completely not help us give any estimate at all. So 90 or 95 is usually where we're going to land. So when we calculate this, we're going to use our point estimate, which is basically going to be our mean of the sample or the proportion we get from the sample, whatever data point we get from the sample, plus or minus, so it's going to be centered at that estimate, the margin of error. And the margin of error is basically going to be calculated with two parts to it. All right, we're going to use some critical value, and we're going to have the standard deviation of the statistic. And so it is going to, basically, this is going to give us some specified distance away based on two factors: what the distribution looks like and what our confidence level is. So let me break that down a little bit further. We got critical value, we have standard deviation of the statistic. The critical value is based completely on my confidence level. And what I mean by critical value is usually that's going to be tied into a certain z-score or t-score. We'll talk about t-scores when we get to section 3. But for now, it's basically going to be like a z-score for normal distribution. We're going to basically say, okay, I want a range of values that 90% of the time is going to get this. And we're going to basically do an inverse norm to get a percentile that will tie into a z-score. Again, we'll deal with the details of those calculations next week. But for right now, what you need to know is that it's basically tied to a z-score, and that depends on the confidence level. So if we have a 95% confidence interval and we're getting a z-score, that z-score is going to be the same every 95% confidence interval we do. In fact, usually by the time we do enough of them, people just, if it asks for a 95% confidence interval, by the end, people have kind of skipped the process of finding it on the table or on the calculator and have just memorized that the value is 1.96 by the time it's there. And maybe have memorized the 90% one too, just because it's almost always 95 or 90. So it is based on a z-score. The other part is based on the distribution, the standard deviation of the statistic. How's the standard deviation calculated? Again, we'll talk more details about it next week, but you have seen the formulas before. For proportions, standard deviation formula is the square root of p times 1 minus p over n. For means, the standard deviation formula is standard deviation divided by square root of n. And so that piece is going to be the standard deviation of the statistic. And the other way that it's called, that you'll sometimes see it called, is called standard error. This entire part of the formula is called the margin of error. All right, so let me back up and go through that again, because it's important that you understand the difference between margin of error and standard error. The standard error is going to be the standard, whatever standard deviation formula we're using. For proportions, it's going to be that square root of p times 1 minus p over n. For means, it's going to be standard deviation divided by square root of n. It is just that standard deviation formula. It is just that piece. The margin of error is the entire part of the formula after the plus or minus. So those are two different things. So if it asks you to calculate the standard error versus calculating the margin of error, those are going to be two different things to calculate. And so we are going to have the part of the formula is going to be the statistic, the data point we're centered around, plus or minus some margin of error. And this format is how it is going to be given to you on the AP test. How this confidence interval formula is going to be given to you. It's going to be written out as this in these words: critical value times standard deviation of statistic. And what we're going to do is, depending on the distribution, we're going to plug in what is our statistic, what is our standard deviation formula, what are we using for our critical value. And we're going to kind of fill in the gaps with those pieces depending on what the distribution is that they're giving us. Again, we'll actually do those calculations later on down the line here. Let me go through another slide that goes through it again. Properties of confidence intervals. Before I do that, here's the formula again. So this is usually some kind of z-score. standard deviation of the statistic. This is called standard error. So if it asks you to compute the standard error, it's asking you to use whatever standard deviation formula we're using. The entire part is called the margin of error.
Formulas for the standard error, or the standard error?
They'll be on future sets of notes. We won't be calculating them yet.
Okay.
They're formulas we looked at last chapter, and they're going to come up again.
Oh, okay.
That's what I'm saying. You had your hand up as well earlier.
You answered it. I was wondering what the critical value was. It's a z-score.
Yes, it is basically going to be a z-score. Again, details about the calculations are what we're going to do in the next section, because it's going to be different for means than it is for proportions. And that's what a lot of chapter 7 was setting up some of those formulas so that you've seen it before, so that when we put it all together over here, we've seen the building blocks of it. And we just need to slot the blocks into the right place. That's what these formulas are going to consist of. So they're going to look a little complicated, but they're all going to follow this structure. And so once we have kind of pieced together what goes where. All right, properties of confidence intervals. Here we go. I already talked about that. Margin of error is the entire part after the plus or minus. We're choosing a confidence level ahead of time, usually in a problem. If a problem asks you to make a confidence interval, it's going to tell you to make a certain percent confidence interval. And the margin of error follows from this choice. More specifically, the critical value is going to entirely depend on what is the confidence. Is it 90%, 95%, 80%? Is going to determine what our critical value is, and in turn is going to determine what our margin of error is. Greater confidence is going to require a larger critical value. So if I want greater confidence, I want to be factoring in potential candidates that are farther away from the mean that I get. So that's going to give me a wider interval. In other words, a 99% confidence interval is going to give me a wider range of values than a 90% confidence interval. So 99 is going to be wider than 90, and that's going to come from the fact that my z-score that I choose is going to be larger because I'm farther away from the mean at 99% than I am at 90%. So wider interval for a larger confidence level. Standard deviation depends on the sample size. So if you think about those standard deviation formulas, the sample size is in them. And where is it in those standard deviation formulas? It's on the bottom. Square root of PQ over n. Standard deviation over square root of n. So as the sample size gets larger, what happens to my spread? We talked about this last chapter. Sample size goes up. What happens to standard deviation? It's going to go down. Because that means my n, which was on the bottom, gets bigger. Denominator gets bigger means the entire number is going to get smaller. So the smaller my confidence level, the narrower the interval. The larger my sample size, the more narrow the interval. Because that's going to make the standard error, standard deviation formula, it's going to make that standard error go down. All right. One more slide, right? Yeah. One more slide. Okay. Three important conditions. These are all things, I think I even mentioned this one day last week, that these are going to come back. And so here they are. Three things that need to happen when you're choosing, when you're making a confidence interval. Three things need to be true. Number one, random. There needs to be a random sample taken from the population. So normally what we're going to do is we are going to say that a random sample got taken. Normal. Sampling distribution, we're saying we can use an approximately normal distribution. So you should know this from last chapter. Our condition for normal for proportions was n times p and m times 1 minus p, both being at least 10. For means, the condition was n being at least 30. We talked about why that was in the last chapter. For means, for proportions. And then, here's our real 10% condition. We're going to take 10 times the sample size. Is that smaller than the population? And that's to say that our calculation can be close enough to treating it like independent that we can say that it's independent. So random, normal, independent. So here is what making a confidence interval is going to look like. This is going to, so anytime you're asked to make a confidence interval, there's going to be 4 steps that we are going to follow in making this interval. This is going to, again, we're looking a bit more into next week. Step number 1, we'll write these steps over and over again as we go forward as well. If the problem asks, make a confidence interval, this is what it's asking you to do. And because there are so many steps involved, sometimes that's the entire free response. The entire free response just asks to make a confidence interval, and that's the only thing it asks you to do. We're going to follow these steps. And these 4 steps are, again, going to be drilled into your head over the next 4 chapters. We're going to just keep working with it. All right, step 1. We are going to state, you may have seen this structure in some of the book problems as well. Like I've seen it on some of your homework because of how the book likes to write it. And if you've seen problems that ask you to follow a 4-step process, it sets you up for this. This is why it does it. State. This sentence is usually pretty easy. It is just saying, it is just setting up that we're using this % confidence interval, and we're going to use it to estimate whatever population thing we're looking to estimate. That's what you're going to say in your first sentence. You're going to start by saying, we're using a 90% confidence interval to estimate, what was the example? It was the Twitter. The proportion of U.S. adults that use Twitter. Step number 2 is going to be the conditions. We're going to make sure that we have all 3 of these conditions in order to make a confidence interval. Random, normal, independent. there's my 3 conditions. I won't write them all out again. Step number 3. Calculate. So actually plugging all our values into the formula and getting out the interval. We haven't talked about how to do that yet. We'll talk about it soon. Step number 4, interpret. Which is what we practiced yesterday. We're to interpret and say, I am 90% confident that the actual proportion of Twitter users, adults who use Twitter, lies between this and this interval. So what I'm saying is that we are going to get to this throughout the rest of the chapter. Your homework is going to focus on this step and a little bit of this step, and getting you comfortable with doing these 2 things. So you'll notice in the example that we did yesterday, I had the interval calculated out for you, and we were able to do things that way. So those are my 4 steps. We're going to state out what the interval is that we're making. We're going to check our 3 conditions that I just put up there. Random, normal, and independent. We are going to do the calculations, and then we are going to interpret what the interval tells us. So anytime it asks, make a confidence interval, that's what we're going to be doing. And we're going to keep going through that.